The following video gives more examples with continuity. Let's look at the following exercise. So find the value for c, which makes f continuous everywhere. The function f will be the function cx plus 1 if x is less than or equal to 3, and cx squared minus 1 if x is greater than 3. Notice that we're worried about the x value equal to 3 because we're gluing up the two piecewise functions at this x value. So we take the limit as x goes to 3 from below and above. Let's start from below, so we're going to use the function cx plus 1, and we do direct substitution to get 3c plus 1. Taking the limit from above, we're going to use the function cx squared minus 1 and end up with 9c minus 1. Notice that in order for the limit to exist, the two values, 3c plus 1 and 9c minus 1, must be equal. So, setting them equal, we can then solve for c and end up with c equals 1/3. This is the value of c that makes this function continuous everywhere. Let's try another one of these. Let's find the value of c that makes the function f of x equals x over 2 plus c if x is not 4, and 3 if x is 4, continuous everywhere. Once again, we're worried about the function at the value x equals 4 because we're gluing up two different functions at this x value. But this time we don't need to take the limit from above and below because we're only looking at values that are either not 4 or are equal to 4. So we can actually take the genuine limit as x goes to 4 of f of x. That means that we're using the function x over 2 plus c, and when we do direct substitution we get 2 plus c. And we can also evaluate f of 4. And remember, in order for the function to be continuous, the limit must equal the value of the function at 4. So that means that 2 plus c must equal 3. So setting those equal to each other, we solve and we get c equals 1. So that's the value of c that makes this function continuous everywhere. As tips for these types of problems, please be sure to show all of your work in order to get full credit. Make sure that you're writing limit if you actually are taking a limit. And please explain which x values you are worried about before you start showing your work. All of these things are important in order to get full credit on these problems.